Good morning everyone and welcome to this webinar brought to you by VTech Energy. My name is Johan Helén and I will be your webinar host for this event. Together with me I have Irene Helmersson, who is one of our system experts for Aiolos Forecast Studio, and I also have Kristen Modin, who is our senior model developer here at VTech. So today's topic, the essentials of energy forecasting. So this will be a description first, a PowerPoint, and after that a demo of how to use the Aiolos Forecast Studio for your energy consumptions or for your energy generation forecasts. So, if you have any questions during the webinar, you can type them into your GoToWebinar application, which you will find in your right-hand corner. You have a tab that's named Questions, so simply type them in there and we will then handle them in the end of the webinar. If you have any questions after the webinar, if you would like to get in contact with us for a personal demonstration, for example, feel free to contact us at sales.energy@vtech.se. So before we get started with the description of the different forecasting models, I would like to talk a little bit about the company behind this Aiolos Forecast Studio. So we are named VTech Software Group, and we have been around for about 30 years. Today with over 500 employees working with different software, and for the energy sector we have about 150 utilities using our softwares. So we always have the ambition to be the clear choice when it comes to companies that are going to choose a forecasting studio or some other product that is related to energy. There are a few keywords that are important to understand in this demonstration, so let's have a look at those. Multiple weather forecasts. Aiolos can handle more than one weather supplier. In fact, most customers run maybe 4, 5, 6 suppliers in the system. If you have your own supplier today, that's something that we could use and implement in Aiolos, or you can use the one that follows with the system. Weighting. When you weight the different forecasts into one final one, this means that we will make a consumption forecast for each and every one of the weather suppliers that we mentioned. And then these will be automatically weighted, and the system will find out maybe that supplier number 1 is more trustworthy for this series or for this part of the year. So then you will have a higher weighting for supplier number 1 rather than the supplier number 2 to 5. So this is something that is done automatically, as I said, or you can set these values yourself if you like one forecast to be more predominant in the system. Forecast series, we will see those on the left hand side in the system. This means that you can create a hierarchy for your different series. It could be that you have one series that represents one country, for example, and then you have different areas of that country beneath, and under that you have different clients or different sub areas that you would like to make forecast for. So this is just a way to aggregate the series, and Aiolos can handle more than 10,000 series. So it's a very dynamic way to handle them. Adaption is a automatic features that will detect if your client has been increasing or decreasing in size. So Aiolos will use the latest historical outcome and the latest forecast to see if there is some kind of pattern between those two. Maybe the forecast is a couple of percent above or below constantly, and Aiolos will detect that pattern and try to correct the coming forecast with that information so that you get the best possible accuracy. Validation is something that you do after a automatic forecast in Aiolos. You can validate the data in different ways. It could be that you bring in historical data from the same day type or from last week or last year, for example. Or it could be that you make a weather simulation and see what happens with the load if I decrease or increase the temperature for a couple of hours. You can also have a look at the specific weather suppliers and see what is the forecast if I only use weather supplier number 1 compared to the weighted forecast, or you can compare all different suppliers to each other. So let's have a look at the feature list for the software Aiolos Forecast Studio. So with Aiolos you can make both short and long-term forecasts. You can make it for electricity consumption, and you can make it for electricity production like wind power, solar or hydro, for example. You can make the forecast with a resolution of down to 5 minutes. It could also be 30 minutes if you like, of course. You can make automatic or manual forecast, which means that you could have the software produce a forecast every 4th hour, for example, without any manual input. Or you could, if you like, have a more personal approach and have a look at the data and validate the forecast with different tools that we have in the software. So input to Aiolos is of course weather forecasts, and we have a bunch of them that we have put into the software. But if you have your own forecast solution today when it comes to the weather, that could be something that could be implemented into the software as well. You could also import external forecasts, so if you already have a forecasting solution, if you make it manually or if you have another system, that doesn't really matter, but you could of course import that forecast into Aiolos and maybe weight it together with some other forecast or do some follow-up on the accuracy, for example. So this software is not only for the models that we have created, it's also for external forecasts that you could bring in. If you like, you can make your own custom models in the software, and you could also, if you like, validate the made forecast with some different tools, and that could be if you would like to look at historical outcome and compare it to the forecast, for example, or if you would like to make a simulation and see what happens if we raise the temperature with a couple of degrees during daytime, for example. What happens with the forecast in that case? And of course we have a function for follow-up as well, where you as a manager, for example, can see how well we are doing when it comes to the forecasting for different areas or for one specific series, if you like. So let's have a look at the different forecasting models that are included into the software. We will go through each and every one a little bit more in detail here. So let's start with the two top ones, so Aiolos and Celia. So Aiolos and Celia are the two main models used in the system for energy load forecasting, so not for the production forecast like wind power. The forecast length could be 1 hour if you like, or it could be up to 1 year also if you bring in normalized weather into the software. And these two models, Aiolos and Celia, are often applied to forecasting series which has a regular or maybe high weather dependency, and that means that that is a series that reacts quite a lot due to the weather, so if it's a warm day or a cold day, for example. To our help here with the weather dependency, we have multiple weather forecasts as input. There are 5 of them right now, and there will be more quite soon. If you have your own weather forecast service that you use today, there is a possibility to put that data into Aiolos Forecast Studio as well to help the Aiolos or Celia model. The demographic dependency is set by defining the load patterns for different day types. So for example, Christmas Eve is one day type, and that has a specific pattern during the day. And this is done with all the historical values, or for the Celia model it's done with the last 60 days of data. The weather dependency is set by a correlation between the historic load and historical weather observations for a window of plus minus 30 days around the forecasting date. and that is also the window that we will bring in data from the past year. So it's for this year plus minus 30 days, and also for 2014, 13, 12, etc., depending on how much data we have. For Celia, it's for the past 60 days here. In the end, a adaptation is made by a comparison of the last made forecast and the belonging actual outcome. We know that there are some difference in the different markets on when you will receive the data from the TSO. So this could be 1 day old data, or this could be 7 days old data, but still there is a comparison made between the outcome and that forecast to see, okay, are we constantly a little bit below or above the forecast, and the adaptation is made. So the system will learn from its own forecasts and from its own outcome. Let's move on to the Delphi model. So this is also used for energy load forecasting, and in difference of Aiolos and Celia, this is for series that has a quite low weather dependency and often a very random consumption. So this only uses the demographic dependency, meaning what is the social pattern for this specific series. So you can say that it's a time series analysis that we make for Delphi. So maybe for a little bit harder to forecast series that you have. The model Nestor is suitable for district heating or district cooling grids, and these of course have very high weather dependency. And to do this forecast, we have added parameters on, for example, the supply temperature into the grids. We also have the multiple weather forecast as input into this model. The demographic is set by a definition of the load patterns per day type, once again, using all historical values. So this is quite similar to the Aiolos or Celia model. Weather dependency is set by the correlation between the historic load and historical weather observations. So basically to see what type of energy we need into the grid when we have this specific mixture of weather parameters like global radiation, wind speed, temperature, for example. Like Aiolos or Celia, a adaptation is made by comparison of the last forecast and the actual outcome as well. So let's move on to the models for production forecast instead, and we can start with wind power. We have the multiple weather forecast input here as well, and as you can see there are some different models that are represented. If you would like a closer look at those, please feel free to contact us and we can give you a detailed description. You can make forecasts for a horizon of 1 to 240 hours. So you can make them both for trading purposes and also for maintenance purposes, for example. When we get these weather forecasts, we try to interpolate both in a geographic way and in a vertical way what is the exact point that we need to make a forecast for. So if we have one specific windmill, we will take the hub height and the longitude and the latitude. And if we have a bigger park, a bigger farm of wind power, we will take one spot in the middle, for example, that could represent the whole area. The air density is adjusted during the forecast period, so we will take that into consideration as well. The surrounding area of the farm or the windmill is divided into 12 different sectors. And this is done because there could be an obstacle from the east, for example, that could have an effect on the wind, and that is not something that we have from the west. So in that case we need to divide them into two different. There is a automatic weighting between the multiple forecasts, meaning one forecast per each weather forecast input. So that is something that is done automatically by the system to weight these together and see which one has been the most accurate for the latest period, for example, and then you will get the weighting. So maybe we will trust forecast supplier number 1 more than number 2. And as an option, you could also bring in real-time production figures, and that will be a correction for the intraday forecasting. So you will make a day-ahead forecast first, and once you're closing in on the specific trading hours, you will make new forecasts with the correction from the real-time production. For hydropower forecast, it's a adaptive model, and we also have hydrological model inputs here. So it's kind of a water balance equation where we calculate the runoff from different sectors together what the ground storage of water is. So in the end, you can say that this is a regression analysis of the parameters that we bring in. For solar, we have a model that's named Helix, and it's a mixture between the Aiolos and Cilia model. So like them, we have multiple weather inputs, but for this model we focus more on the global radiation, of course. So this is the main predictor, and what we create is kind of a diurnal pattern, which makes the forecast model understand that in the morning we do not have that much production. During the daytime, when it is high global radiation, there is also a high production, and of course at night we do not have any production at all. Last but not least, let's talk about the studio functionality, and what we mean with this is that you can create your own forecasting models in the software. So if you would not like to use Aiolos or Cilia, for example, you can make your own. You can also add other forecasts for validation. You can weight them together, so you can have one forecast made by Aiolos and you can have one forecast made by some other system, and you will bring both into the software for weighting together to one final forecast, which is the one that you will use for your trading purpose. And of course you can do follow-up on both and see which one in the end that was the best and what was the outcome for the weighted one as well. You can have up to 8 models shown simultaneously for validation purposes, so that's something that's very good in the system, that you can validate the forecast that has been automatically laid by the software and see what you think about it. Dynamic fractions allow the models to be used as predictors, and with predictors we mean like the wind speed for a weather forecast. So you can have the different models run, and then you can automatically weight them together to see what would be the best possible forecast that we can make out of these, for example, 3 or 4 forecasts that we have made. So the workflow in the system, this is a very short description of course, but we will start with a automatic import of the latest weather forecast and the historical data, and that could be production or consumption of course, depending on what type of forecast that we would like to make. So once that is done, you will have the configuration, so you can have a look at the historical data. You can see if you have any spikes, for example, that you need to correct. When you have done so, you can simply click forecast, and you will have the automatic check of the data to make sure that there are no erroneous data, no missing values. And you will then of course be alerted if that's the case, and you can choose to ignore that information, you can choose to correct the data, or you can choose to delete the data. So once that is done, you will have the forecast in front of you, and then you can choose if you would like to run with the automatic forecast, if you would like to validate it in different ways. And that could be done with historical data, so you can bring in the same period from the last year and see did we have the same weather for that period and what was the outcome in that case. You can also make weather simulations if you like, so you can say to the model that what happens if we raise the temperature by a couple of degrees during the daytime, and then you will see the difference in both graph and in a table form. And when you feel ready, you can export the forecast, the final forecast, to Excel, or XML or directly to your trading system. And then of course it's very important to make follow-up on the work that you have done, so you can bring in whatever period of forecasts that you would like into the follow-up function and see, okay, how well did we perform during this period of time. So Aiolos Forecast Studio is made for a few different types of users for the entire trading team. So we can start with the managers, and they create reports using the Aiolos follow-up functionality, where they can get key metrics on volumes and accuracy. Then we have the spot market traders, and they are often in for the day ahead forecast and the intraday trading forecasts. So they like these multiple models or multiple weather forecasts together with the validation tools in order to create the best short-term forecasting. The financial traders, on the other hand, they are into the long-term forecasting in order to be able to hedge for the electricity trading. With that said, we are soon going to leave the PowerPoint and have a closer look at what the system looks like. We will go through some different parts. We will check the user interface, a short explanation of that. We will configure the datasets before the forecast. We will make a automatic and manual data check to see if we have any spikes or any gaps in the data. We will make the automatic forecast, and we will then try to validate it with some different tools that I will show you. And in the end, when we are happy with the forecast, we will export it to the trading system. And after that, of course, we will do a follow-up on what does the accuracy look like. And let me remind you that this is demo data we are looking at. Let's move over to Aiolos Forecast Studio then. So this is the user interface of Aiolos Forecast Studio. We're going to show you a few parts of the system, but if you would like a full demonstration, please feel free to contact us and we can arrange that. So what do we have here? We have a few different tabs. We have the Home tab, and this is where you create the forecast. You can have a look at historical data. We have the View tab, and this is where you can validate the automatic forecast made by Aiolos. And we also have the follow-up functionality. Once you have exported a forecast, you can see how did it go, what are the key metrics when it comes to accuracy, for example. And then we have config, and this is a little bit more in the background. So for the Home tab, we can see that we have the series here. We can open that up a little bit so you see what it looks like. So we have some series. In this case we have one named Consumption, which consists of 4 different forecast series here. So this is 4 parts of Sweden in this case. And this black and white part here is what we call a dynamic fraction. So this means that from southern Sweden, which is SE4, we have about 10% of the load. Down here we have wind power production, divided into different areas, and then it could be per park or per turbine if you like. Here we will display the different graphs, and on the right hand side we will have a table form where you can see the data points per hour, what are the values. And down here we have the total, so that's the same thing but for the daily amount of electricity that we need. To make a forecast, we can choose to tick in what boxes we would like to make a forecast for, or what series. Or we can choose a ready template that we have here that's named Consumption. So we'll click that, and we have these 5 boxes ticked in. We could also say that to the system that we would like to see all forecast series or only the ones that are checked in this case. Now I have so few, so I will keep all here. We can make a search for a specific series if we like. And then we will set the date and the period of the forecast. We can say that we would like a 48-hour forecast starting at hour 1 here. One important thing that we could do first is to have a look at historical outcome, and we can bring in the last 2 weeks, for example. So here we see 2 weekends and the belonging data in between. Down here we can see the global radiation, which is the yellow spikes. We can see the wind speed, the green graph, and the temperature is the red graph. And once again we have the same data in a table form on the right hand side here. So it seems that the data looks quite fine. We do not have any spikes that we need to correct. The next thing to do is that we could either run a forecast, or we can click on this icon here and we will check the data status to see if we have any runners data in the historical database. So it could be that we have 0 values, for example, and then the system will alert you that that is the case and you have the possibility to do something about it. In this case we will simply run the forecast. So now we can see that 2 more days appeared here, and this red line is where we are right now. So this is the hour that we are in at this case, or the 0 hour for the forecast that we are making. What we can do now is that we can move on and we can take away the historical data if we like. We can keep it and we can click on this View tab. So now you can see that the header has changed a little bit. So once again, this is where you can validate the forecast, and you can do that in a few different ways. You can do it by historic comparison. So this is where you can bring in different dates and compare the forecast and outcome for those days. Or you could have a forecast comparison. So this could be that you would like to see both the Aiolos and the Cilia model, not only combined. Or you can make a weather forecast, and adjusted weather means that you could, for example, make a simulation and say that for these specific hours I would like to see what happens with the load if we raise the temperature by 3 degrees. So you can basically see how weather dependent this specific series, or in this case some series, is. If you click on alternative, you could bring in one specific forecast, production forecast, that is made with one weather supplier. So in this case the gray line represents a weighted forecast between 5 different suppliers, but if we click on alternative we could compare this one to number 4, for example. And then we have some export functionality that we will show you in a bit. We could actually start with historic comparison, and I will click here, add. And if this is a forecast for Christmas Eve, we could choose to bring up some more Christmas Eves to see what does that data look like. Or we could choose the dynamic date, and this is where you can, from today's date, which is 00, we could go back 1 week in time if we like, or several weeks, or we could go back, for example, 1 year in time and see what does that data look like. We will bring up 1 year here. So I will name that year -1, and we click OK. So now we can see that we have 2 graphs up here. The gray line is still the forecast that we are working on, and the blue line is 1 year old data for the same 2 days. And as you can see, the timestamp says 2012, and this is simply because it's demo data that we are looking at. We have some more information on the global radiation, wind speed and temperature. We can see that the temperature seems to be a little bit lower for the last year's data compared to this year, but we have a spike in the global radiation which brings up the temperature in a little spike here as well for a couple of hours. And we can see that for the colder period we have a quite large difference in the consumption between the forecast that we are making and the historical data from last year. What we can also do is that we can make this weather comparison, and we can make a simulation that's quite similar to the small spike that we have here in the data from last year. So it seems like it starts somewhere around 1 p.m. and goes on for a couple of hours, and we will raise the temperature, let's say 3 degrees. We click OK. So now we can see that we have 3 graphs. We still have the gray one and we have the blue one from last year, but now we also have a green, and this is the simulation of the raise in temperature here. And if we look closely down here, we can see that we have the graph that is the temperature that is forecasted, and here we have the simulation that changes a little bit. So the dotted red line here is the simulation that we have made. We can view that a little bit more easily, maybe by taking away the global radiation like this. We can see that this simulation has an effect on the consumption. We can see that for the hours that we are making the simulation for, the consumption gets a little bit lower here, and it still goes on a couple of hours later. So this is not only something that affects the hours 1 to 3 p.m., it's still going on at 6, 7 p.m. in this case. We can choose this simulation, and what we can do then is that we can drag and drop the data points in the graph like this. Take each and every one and make a change, or you can choose a specific area and make a change that is applied for all those data points within that area. Once we have made a change, we can have a look here in the table form, and we can see that adjusted load in percent, we can see that for these hours we have decreased it by 1 to 3% maybe. And here we can see the adjusted load, and this is what the load is after we have made a change, and this is what the load was before. So this is the export that we will make in this case here. And the same goes for the totals. This is the originating load, and this is the adjusted load that we have here. We can choose to make some more validations, and what we will start with then is to take away last year's data here, and we can have a look at this box here. So what we can do here is that we can compare this forecast that we have made, which is a weighted forecast from 5 different weather suppliers, and we can compare what does this look like compared to number 4, for example. Like this. So as I said, this is the forecast, production forecast from the weighted between the 5 different suppliers, and we will compare that to the production forecast from only supplier number 4 in this case. So here we have it. We can see that it's a little bit higher for this particular period of time here. If we like, we could mark one specific area, as I said before, and we can make changes to that one, or we can zoom in like this. So here we can see the simulation that we made before, and we can use the arrows on the keyboard to step up or down and have a closer look at the data and make some small changes if you like. Once you feel ready to export, you could choose what data would you like to export. In this case we have made a forecast for 48 hours, but I would only like to export 24 in this case here. You can export in different formats like Excel, XML, or we can set up a script to send it directly to your trading system or whatever system that you would like this forecast to be sent to. So that could be a completely automatic workflow. The forecast could be made completely automated and sent to the trading system, or you can make it a little bit more manual like we have done now and make some validations and then click export. So that's how we make a forecast in the system. As I said, there are some more things that I haven't showed you right now, that we can have a closer look at the personal demonstration. Let's move on to the follow-up tab. So one important thing with forecast, of course, is to make a follow-up and see how well we have been producing forecasts, and that you can do with this generator here. So we will choose what dates that we would like to have a look at, and I will bring up the historical data in this case here, and I would like to have a look at 1 week worth of data, and always have a look at the day ahead forecast. So you could have a look at different parts of a forecasting scenario. So it could be 48 hours, it could be a kind of an intraday forecasting that you would like to make a follow-up, and then you choose that. We have our series checked up here, and then we click calculate. We can start with series number 1 here, and we can see that we have the historical, the real outcome, and we have the gray or the black line here, which is the exported one. So we can see that a few days follows quite well, and for a few days the demo data is a little bit off in this case here. We could also compare what does the real wind speed looks like to the forecasted one, and the same goes for the temperature. Down here on your right hand side we can see the mean absolute error for this specific series, and we can click on the next one and see what it is for that case. So to sum up the follow-up functionality, the system could be configured so it produces tailored reports for your need. These could contain the possibility to see each series if you like, or it could be a total amount that you would like to have in the module. You can view automatic or manual forecast if you like, so you can compare the forecast made by Aiolos and the one that you have validated. You can view any time interval that you like, so you can compare a intraday forecast to a day ahead or 2 day ahead if we are talking about a forecast for a weekend, for example. We have a few minutes left, and as promised before, we will handle some of your questions. It's not too late to type in your question. You can add it in your GoToWebinar application on your right hand side. You click tab questions and type it in, and we will handle as many as we can. So for this session I will bring in Irene and Krister, so you guys can click unmute, and we will take the first question.